Hello and welcome to the LS Telcom web seminars. It's about time again. Finally, our web seminars enter the next round, starting today. My name is Larissa Behrendt and I'm your host. This is the first seminar of the series Smart Spectrum Solutions for Telecommunications Regulatory Authorities. I hope everyone is tested, vaccinated, and recovered. Just joking, I'm trying to loosen up the atmosphere because this is what we want. We want you to feel comfortable with asking questions at any time. We want you to enjoy the seminar. And most important, we want you to take interesting insights and instructive facts with you from this format. So today we're starting off with the first web seminar called Spectrum Regulation in a 5G World. 5G brings with it a range of new challenges. Finding the right spectrum to enable all of 5G's benefits may require extensive refarming of existing services. Licensing 5G, especially to both vertical and mobile operators, requires careful balancing of supply and demand. In addition to spectrum, new approaches may be needed to licensing, authorization, and infrastructure readiness. Before my colleague Saul Friedner from LS Telcom UK will start introducing the shortly mentioned issues and share some of LS Telcom's experiences in helping regulators around the world successfully introduce 5G, let me briefly introduce LS Telcom to those who may not know us yet. LS Telcom was founded in 1992 in Germany. Ever since, the company has substantially grown, today counting close to 250 employees in over 10 countries, which is pretty cool, I think. LS Telcom nowadays represents a globally leading supplier of system solutions and consulting services with the aim of unleashing the full potential of the radio spectrum. As such, we deliver fully integrated spectrum management systems, radio network planning tools for different radio technologies, and of course, automated radio monitoring systems. In addition to the system solutions, we also offer consulting and engineering services. Our consultants are experts in the fields of regulatory policy and strategy, business planning and development, network planning and optimization, monitoring, and much more. Until today, we have provided our products and services to customers in more than 100 countries. Both our system solutions and our consulting services are based on a global know-how and experience that we have gained in more than 29 years of operations. Now, let me come back to today's web seminar. The seminar is scheduled for 45 minutes overall. After I stop talking, Saul's presentation will last about 30 minutes so that we have at least 10 minutes to answer any questions and answers, or how people on YouTube would say, it's time for Q&A. You are more than welcome to ask or pose questions during the web seminar using the chat window, and we will answer as many as possible during the Q&A session. The web seminar will be recorded and made available for you after the seminar. You will receive an email within the link to the recorded seminar. Now, let me conclude with the introduction. Thank you for joining, and I will hand over to my colleague, Saul.
Thank you very much, Larissa, for the kind introduction. So my name is Saul Friedner. I'm the Associate Director of Spectrum Services for LS Telcom in the UK. And today's session we'll be talking about spectrum regulation in the 5G world, as Larissa just mentioned. And although 5G may be considered no longer such a new technology, it still raises numerous questions and challenges for regulators as to how they can support the market and the mobile operators for gaining access to the right spectrum in the right time, so that deployments can be made in a timely way. So for this session, there are kind of three areas that we're going to cover. So we'll talk about 5G progress in the 2020s, So in the next decade, how 5G will kind of progress towards rollout and coverage, and where kind of the key areas, successes, the performance against the promises of 5G. We'll talk about spectrum availability to support 5G rollout, the specific bands and bandwidths and the varieties of bands being used. And I don't know, you may be surprised with the additional number of bands that 5G is able to support compared to 4G. And then also the challenges of 5G deployment and how regulations are there to help stakeholders and operators and enterprises gain access to the spectrum, as I said, in a timely way, so that successful deployments can be made in the market. So that's our kind of overview of the topics that we're going to cover today. So I will get right into it. So let's start with the number of deployments at the moment. So this is a chart from the GSA's 5G market report as of August 2021. I think it's a very useful map here to kind of track progress of 5G commercial deployments around the world. The reports that they actually produce are free. If you register on the GSA's website, you can actually, you don't have to be a member. These kind of reports can be downloaded for free, certainly the executive summary part. So I think they're a very useful way of kind of tracking the progress. And on this map, you can see in the dark blue are the actually commercially deployed 5G networks around the world. You have the purplish color, that's the pre-commercial launches, so you can see the likes of Russia and so on in the kind of pre-commercial phase. Then you've got the orange that are planning 5G networks. There's a lighter blue color in there, but there's not many examples of soft launches. And the kind of pinky color is in the process of deploying. And then we have the green countries where it's either evaluating or testing. But I would say that 5G has been growing at a faster pace than 4G, as there are now 175 commercial 5G networks, with about 300 or so kind of being investing in networks themselves. So, you know, out of the almost 1,000 or so operators around the world, we're getting to a point now where maybe half of those operators are now either investing or deployed their networks. And I would say the reason for such a fast pace of deployment for 5G in particular is because of the readiness of operators. I would say that with 2G, 3G and 4G, infrastructure has been deployed extensively in many countries, with multiple bands being deployed at the macro sites, for example, and also with kind of infill sites also being deployed with additional kind of spectrum being overlaid for capacity. So I think there was a level of readiness already there for operators to be able to deploy and roll out or upgrade to 5G. I think also there's consumer demand as well has kind of driven that pace. I think as speeds within 4G have increased, I think demand for data by consumers has also driven the rollout of 5G. I'd also like to mention that there's a strong political push, I would say. I'd certainly be interested to hear people's views, maybe at the end, that some countries have actually, as we've learned from experience, developed their own 5G national strategy, and that's coming from a regulator or even the government's perspective as well. So we can see some political drivers that are kind of setting out particular targets, and this is most notable from our experience by the European Commission, who are encouraging 5G deployments. There are a mix of level of investments by operators to speed up the upgrades of existing sites with new antennas, base stations, and obviously applying the new frequency bands. The network upgrades can be done quite quickly in some countries where there is already that extensive infrastructure, as already mentioned. But also to mention that what this actually means, although these are deployed networks, does not necessarily mean the coverage is extensive in those countries. To launch a network, you simply have to cover like a single town or maybe a few towns in the first kind of rollout, and then obviously build up from there. And that's what operators have been doing. But in Europe, the European Commission set a target in 2016 for commercial rollout of 5G to be in at least one major city in every country by the end of 2020. Unfortunately, that target's not been quite met. I think some countries have struggled, only a couple, I would say, to get the spectrum out into the hands of the operators. So it is still quite a challenge to get the spectrum out there. But for the next decade, the Commission's digital decade, that aims to have all households in Europe covered by gigabit network, with all populated areas covered by 4G by 2030. So still quite a challenging target to meet, I would say, particularly to cover all populated areas. So there are some questions over that. And then clearly you can see in the map there's in Africa in particular, there's still quite some way to go in terms of deploying mobile networks, 5G networks as well. So perhaps unlikely to see any commercial networks in Africa until either mid next year or late 2022. So in terms of the developments across frequency bands, so this is another chart from the GSA 5G market report as of August. You see here the top 3 bands. So apologies if this is quite small text, these frequency bands. Hopefully you can all see that. But you have the C band at the top, the 3.3 to 4.2 gigahertz and 3.3 to 3.8 gigahertz is clearly the most popular band for deploying 5G, with 250 deployments or licensed or in evaluation as well. But certainly, in terms of usage by operators or regulators and so on, it is the most popular. And just to mention, these top 3 bands also includes the kind of 26 gigahertz band on the millimeter wave band, and then also the 700 megahertz frequencies as well. And again, and we're not wanting to focus too much on Europe in this presentation, but those 3 frequency bands were identified or grouped together as pioneer bands. And so it was seen that these frequencies could be used to launch 5G in Europe. So as I mentioned earlier, a dedicated kind of political driver to help countries deploy 5G in a manner that will certainly unlock access to the right kind of spectrum bands. So C-band has been seen as, by many regulators around the world to be the most useful and popular for 5G. However, the problem with C-band is its use varies widely across the world. So in Europe, has had some existing usage, certainly around satellite, but certainly not as predominant as you may find in Asia, where C-band is largely used for TV reception. So the difficulty for some countries, say like in Asia, where it's highly utilized, starts to become a problem for gaining access or clearing the band or making it available for mobile operators to use for 5G. So again, from LS Telcom's experience, we've seen that countries where they have these difficulties may have to consider their options for the amount of spectrum to be made available. Maybe not all of it can be made available because of incumbent usage, or the introduction of guard bands to protect existing adjacent incumbent usage as well. So there are some challenges there, but also again in other countries where there might be some fragmentation and existing licensees, there have been approaches to clear the band, which can take time. Sometimes it can take years to clear all of the existing users out of the band, so it can be made available for 5G and then for award and auction. Just to mention about the 700 megahertz band, which here you'll see there's a multiple set of flavors that could be used for 700. This is mainly driven by the standards, where there are different channel arrangements for 700 in different countries, and these all get supported by the 3GPP standards. But you can see this is not as prolifically deployed or used. I mean, there's still something like 75 odd networks that are using the 700 megahertz band, but it certainly hasn't been as highly utilized as C band, or as even 26 gigahertz band or the millimeter wave band. And I would say that's because 700 is a lot harder to clear. Again, in some countries there's the broadcast allocations that are in the band, and there are challenges around clearing that spectrum to be made available for clearance and use for 5G and auctioned. So and the other reason I guess is also the 700 megahertz band could come with some level of coverage obligations, potentially not making it as popular as some of the other bands if a license obligation is applied to that frequency band. But I guess the benefit of it is it gives the extended coverage beyond the urban areas into the rural areas, and usually deployed on the large macros to give that wide area coverage. But it doesn't have the large bandwidths, nowhere near the large bandwidths that you would get at C-band, also in the millimeter wave band. So in terms of trying to achieve the performance that you would expect for 5G, the 700 megahertz band only really gives each operator about 2 by 10 megahertz of spectrum, which doesn't really provide the level of capacity that you'd expect to deliver the data throughputs that 5G is promising in terms of those data throughputs. But it's also worth noting, you'll see here there's a long list of other frequency bands that are now being utilised. Again, not in great numbers, but there are other millimeter wave bands being used, lots of mid-band frequencies around 2 gigahertz or L-band or in the 4.4 gigahertz band and so on. And this is mobile operators utilising their existing spectrum assets. And the other reason this is occurring is that mobile operators are also switching off their 3G and in some cases 2G networks. So in Switzerland, Germany, Norway, and Norway have been switching off their 3G networks, and Vodafone have switched off 3G in Czech Republic, Italy, and the Netherlands. And we think that 2G, there have been announcements for 2G switch off later in 2020. So it's just worth noting that there's a wider portfolio of frequency bands now being used to, I guess, help speed up the deployment of 5G by many operators. So in terms of, so we've looked at the rollout, deployments, the progress of the rollout and the popular frequency bands, but what is actually driving 5G? And I know there's lots of debate, there's been lots of discussion around, how 5G will help kind of drive vertical uses and a number of different use cases. But at the outset, with the first definitions of IMT 2020, there were kind of the 3 clear use cases, which were the enhanced mobile broadband, the enhanced machine type communications or kind of the IoT, and the ultra reliable low latency communications as well. So like the three main use cases. And over time, I think clearly in terms of what mobile operators have been keen to do is get the networks deployed, get consumers signed up and joining the 5G network, so selling the enhanced mobile broadband offering, so that at least there's a return on investment from the initial outlay on the spectrum bands that they've paid the perhaps billions of euros and dollars on the spectrum, and that's in order to get the kind of the return on investment, and then maybe focus on some of these other use cases where it's a slightly more challenging approach to deploy or make deals, let's say, for some of the networks. So in terms of the way we're seeing the pattern of deployments, you've got the traditional cellular mobile broadband to consumers, but then you'll have a whole range of different use cases that 5G can support, and a whole range of different sectors. So there's the utilities and energy sector, transport, industrial automation, satellite, backhaul for satellite is another area, and massive IoT. And the chart here shows an estimate of the revenues from 5G. Again, apologies, this is quite European focused, but there is a lot of information, a lot of analysis that has come out of Europe, given the big push. But there are these kind of 4 different areas, notable areas. So you have this extreme mobile broadband, as you can see here, which is clearly the most popular with the highest levels of revenue expected by 2025. You've then got fixed wireless access, which is, like I would say, an emerging area, something that the mobile operators have perhaps pivoted towards as they've seen an opportunity to utilize their spectrum assets and the model for providing kind of high capacity stationary broadband, ultra fast, and they can provide that perhaps quicker than the some telecoms companies can deploy, say, fiber. So the kind of competition there would be with the fiber players and getting the kind of a more cost-effective way of getting the high-speed access to those end customers. You then have this massive IoT, which I mentioned, which is these large deployments of sensors, in kind of agriculture or anywhere, where there's a requirement for lots of sensors, but the expectation there on the kind of low cost and very deep coverage. And then the mission critical IoT is the ultra low latency and the high reliability. So these are, as I said, these are some estimates, and clearly the extreme mobile broadband is the largest contributor to the level of revenue that's expected. But you can see that massive IoT and mission critical IoT will also contribute quite significantly to the potential revenue that you might get from the different services from 5G. So this is really a view from a range of consultants. You can see who's been contributing to the input of of these numbers. So some quite kind of major players in the industry who are tracking the progress of 5G and seeing where the deals are being made beyond the consumer mobile broadband. So I think this is just to give you an idea of where 5G, even in say 3, 4, 5 years time, as it's kind of really maturing outside of the consumer broadband area. So I think that's just a useful position to see. And as it says here, it's kind of mixed service provision. So it won't just be MNOs that will be providing these services either. It's worth noting, and private network operators who will need access to spectrum as well, I think will also be important, and we'll talk about that later on as well. So it's worth kind of noting that. So we talk about how then regulators can decide on kind of spectrum release. So we've talked about what's happening in progress with spectrum bands. So it should be clear where the kind of popular bands are. But I think it's useful to kind of talk about what regulators, or what we've seen from our experience working with regulators, how they have gone about kind of making and preparing for providing access to the to spectrum to the market. So we've been involved in setting out national spectrum strategies or master plans for regulators. These are usually long-term, 10 years, usually spectrum master plans where you'd identify the bands based on forward-looking, where the regulations have been kind of pointing to potential changes in the regulations around certain allocations and bands, and introducing views on where new release could be targeted within that time frame. I know it's very difficult to look 10 years ahead, but typically that's where the master plans look, and they don't necessarily align fully by the end of the 10 years, but it's always good to have that strategy. Often the market and technology development can speed up the time frame, or sometimes introduce a delay if the timings do not align. So having something set out with something kind of slightly flexible, I think, is also helpful. So it's not necessarily a problem, but vital that regulators are prepared. Updating regulations in line with the latest ITUR regulations, of course, is very important. The WRC outcomes provide that opportunity to update the national regulations and frequency allocation tables. And as LS Telcom knows from experience, some of the challenges and decisions that vary across regions, particularly, and also between neighbouring countries around kind of adopting the national frequency plan as well, outside of the from the outcome of WRC. Alignment with technology developments and keeping pace with innovation is a must for regulators. Therefore, tracking developments like 3GPP, as you can see the timeline here on the right-hand side, give an indication of when to expect commercial equipment to be available on the market. Consulting with stakeholders is also important, and lots of regulators do this to capture the feedback from the market on regulatory proposals. So this helps the regulator to hone the specific frequencies and determine what the market would prefer. It could also add, potentially adds slight division, particularly if there's a market, if there's a clear objective and there are two sides to the particular proposal. But usually what we find after a consultation is done, there's usually a large, there's a majority that is in support of the particular proposals, and there's hopefully a quiet minority that also that might disagree. But usually it's quite straightforward. Trials and test beds is another useful way to get spectrum in the hands of operators early, so they conduct trials and performance before the spectrum is made available officially. And then in response to kind of stakeholder feedback, this could be consultations or even the trials, the regulator could make adjustments to the bands to accommodate more players in the market, or introduce certain interventions, in order to protect adjacent incumbents. And then finally, the alignment with regulatory principles and market conditions, ensuring the promotion of spectrum efficiency and innovation. So just a few thoughts on how regulators can kind of release some spectrum into the market. So in terms of, just wanted to highlight at this point kind of how 5G has been able to kind of emerge in the way it has done, and we've already mentioned the kind of the three key bands, and really just to kind of make a couple of points here in the fact that 5G is about two types of networks. You've got a coverage network, which is using the 700 megahertz band. You then have the capacity network that uses the millimeter wave frequencies that can serve those high capacity peaks, where the expectation is for dense urban areas. But what it does, looking at it in this way, is allows you to start thinking about how this spectrum can be made available, how there needs to be a level of flexibility in making some of these bands available to the market. So we take 700 megahertz, where kind of highly wide area coverage, low levels of opportunity for sharing, quite possibly, where on the other hand you've got the millimeter wave band, kind of 26 gigahertz frequencies, where kind of low range, there's a low range from each of the cells, and there's like a high probability of sharing. And then you've got the C band in the middle, where there is a bit of a mix. You've got the enough spectrum to deliver the capacity, and there could be some potential sharing depending on where these frequencies are deployed. And that's how we see, or what we've seen, how these bands are kind of being made available to the market, and what regulators are, what decisions regulators have been making with regard to these bands. So what we'll do from here is go through some of the different authorization options for some of these frequency bands. So we've looked at in the past, and I think those of you that are from a regulator on the webinar will be fully aware of how some of these bands have been made available if you've already made the spectrum available to the market. So you have the existing authorization models, for example, individual exclusive access for frequencies below 1 gigahertz, such as the 700 megahertz band. And making that available via auction has been, kind of the most traditional approach. And I think going forward in future, that will continue to be the case. It's unlikely there could be a different model used for this frequency band, and that's because there's limited number of limited kind of bandwidth available, but also there's limited opportunity kind of for sharing, given the wide area coverage it will offer. So we would expect that to continue. In the C band range, again, I'd say most countries have auctioned the spectrum over the last couple of years. Certainly, kind of in the UK and in Europe and in other countries around the world have auctioned the spectrum. But given the kind of the characteristics of the frequency bands, the much lower range compared to 700, does present a level of opportunity for sharing. And if mobile operators are looking to deploy this frequency in the dense urban areas, serving the capacity in those areas, there's an opportunity for that spectrum to be used elsewhere. And we'll talk later on about some of the models that are being used in other countries where that has actually been the case, and that opportunity has been taken up by those countries. I think the most obvious one, I think for everyone who's joined the seminar, hopefully will understand that for the millimeter wave bands, where there's a much lower range, much lower kind of cell range, the opportunity for sharing is a lot higher. And it's such a new area for mobile operators to be involved in for using this particular frequency. And I think from a regulatory point of view, this does allow there to be kind of some flexibility. Now, it's worth noting that in the early days, some regulators have actually auctioned the spectrum, 26 gigahertz, and actually made it kind of like a nationwide license. But it could be argued that there's an opportunity to be taken here to be a lot more flexible, noting the ability to be able to kind of share this spectrum and utilize some different authorization models. So in the UK, there is a low power indoor access for 26 gigahertz as like an underlay use of this spectrum, which is a flexible approach. It's only a small part, or a smaller part of the frequency band that's been authorized for that usage, but it just is an example of how different models can be used for authorization, for each of the different bands. And I think what this is demonstrating is it's not like it was before. It's not like it was in 3G, where you'd simply auction the spectrum. There might be a coverage obligation. The mobile operators go away 2-3 years and they have to deploy. We are now talking about multiple different frequency bands, all with different authorization models, which kind of adds a level of kind of complexity that wasn't there previously. So it's just kind of like worth noting that in terms of the difference between what life was like in the earlier days of 4G. I will need to speed up a bit because I haven't got much time left. This slide really is just to give some examples of what I mentioned earlier. So you've got now in C-band in particular, the 3.4 to 3.8, where some countries have looked to, so particularly in Germany, if I mention Germany, would be a good example, they've dedicated a slice of spectrum in the 3.7 to 3.8 gigahertz portion, dedicated specifically for verticals, for private networks and enterprises to be able to deploy their own private networks in that piece of spectrum. Not a very popular decision, I would say, certainly as far as the mobile operators are concerned, given they've spent billions of euros on their frequencies, whereas enterprises, like the manufacturing sector, who can deploy their own private networks, are spending tens of thousands of euros on licenses to deploy their own private network. So definitely an interesting approach by Germany. You can see there's now 148 5G campus licenses, which gives an indication of demand dedicated verticals, but I think this might be a slow burn in Germany in terms of kind of uptake for this particular frequency arrangement. There are examples in France where there's private licenses in 2.6 gigahertz, and there's now spectrum sharing and local licensing in the Netherlands, Sweden and the UK. And in the US, there is the CBRS model, which is used to support the rollout of private networks as well. So I'll quickly try and get to the end of this presentation. So I wanted to talk quickly on some of the challenges that face regulators, and this is just an example of the experience that we've had. So as I've already mentioned, the choice of spectrum release models, the fact that there is multiple bands that can be made available and that support 5G, and that regulators then need to kind of look at their portfolio of spectrum, what can be made available and how, what would be the impact on incumbents if there is a large density of existing licensees in those frequency bands that are being identified for use by 5G. So decisions on the appropriate frequency bands, and then also on the authorization model. And this can be a challenge. It has become more complex, particularly for 5G compared to 4G. Support to infrastructure rollout. So although not necessarily a regulatory function directly, it's certainly useful for regulators to know whether it's easy or difficult for mobile operators to actually deploy infrastructure, particularly if there's a coverage obligation that's been put on the license. So if a coverage obligation has been put on a license and yet it is difficult to deploy infrastructure, meaning it's a challenge for them to meet any particular timescale, then this is going to be a problem. So it's useful for the regulator to be aware of any ease or restrictions that can be lifted on planning permission, for example, to allow mobile operators to deploy infrastructure on street furniture or on private private buildings or something like that, and also a consideration for infrastructure sharing options and making sure there's kind of full regulatory oversight if such a thing is needed for that type of approach. Another area that's kind of coming up quite a bit more in 5G is the EMF regulations. So these are the kind of radiation hazards around antennas. Given the kind of active antenna systems that are being deployed in 5G networks today, there's kind of a growing concern, maybe risk, that some of the safety levels, radiation levels are being exceeded. I mean, only concern because it's a new system, so there's been perhaps an extra focus and attention on making sure that that these newly deployed antenna systems kind of meet the ICNIRP limits, and clearly, that they all do. But it's obviously worth ensuring that that this is that the regulations are clearly stated, and the levels can't be exceeded to ensure that these can be deployed safely, and there's no risk to the public or anyone working close to the antennas are safe. And obviously, having the appropriate regulations in place to ensure that is also going to be important. And of course, cybersecurity is a very important aspect. Ever present. Regardless. Going back to even 2G, obviously not as maybe security focused as perhaps 5G, but ensuring that there's kind of open and transparent policies around vendors, and obviously having a robust and current cybersecurity policy to ensure that that networks are also safe and there's no risk to kind of consumers or any kind of security concerns there. So just some final other regulatory considerations. I think it's just worth mentioning a few points here, given the very topical discussions that have been going on globally. Just wanted to mention decisions on the allocation in the 6 GHz band and the debates around access for Wi-Fi and 5G. Obviously, there are kind of big debates going on around the world, particularly between the likes of GSMA and the Dynamic Spectrum Alliance, where they're trying to kind of both get their hands on the spectrum. Some countries have already made the entire 6 GHz band, so from 5925 to 7025 or 7125, available fully for Wi-Fi in the US, Brazil and Saudi Arabia. So that's completely for Wi-Fi, where I believe China have made the full band or intend to make the full band available for 5G. So there's a bit of a new territory of a battle, if you like, for this particular band, and it'll be interesting to see how that kind of plays out. But we are, LS Telcom have been involved in some of these debates, and it's very interesting to see what will happen. But there's certainly strong views from both parties arguing the need for access to this particular band. Also, decisions at the WRC may impact access to more spectrum for 5G. There's just a list of the frequency bands that are given on WRC for more discussion and agreement. So you've got the upper portion of the 6 GHz band on there, and then also the 10 to 10.5 gigahertz as a potential new band for 5G. Also worth mentioning, there is research underway for 6G. And so there's a need to perhaps understand the regulatory implications on frequencies to be used and the types of infrastructure. So my understanding at this stage, it is all very kind of research focused, and papers being written at the moment. So that is more about about that. But yes, there's talk of the very, very high frequency terahertz type frequencies being used for these the types of networks that they plan to deploy for 6G. And one more thing to mention here is a move by some regulators to support vendor diversification in networks. And we're starting to see a more open and transparent approach by certainly operators wishing to be able to diversify their supplier pool, so they can have a lot more flexibility, support kind of innovation. And we've also seen regulators, so like Ofcom, getting involved in programs that are supporting and promoting innovation and helping the continued evolution of networks, kind of performance and so on, by supporting this kind of vendor diversification. I think some of it may have been driven, or possibly been driven by, some vendors being kind of removed in terms of accessing the network by operators. So ensuring that there's still a diverse pool of suppliers that operators can choose from in terms of vendors and equipment suppliers. So this is my last slide. Just a quick one about LS Telcom and our, it wouldn't be a proper webinar without this, really just to explain that we have been involved in many projects for regulators and other organisations around the world, helping them to kind of understand some of these issues that we've discussed already. And, we do a lot of technical analysis and feasibility studies. We have supported 5G national strategies, and taking kind of different, they've looked at different focuses around use cases and the economic impacts as well. International regulatory support, so the outcomes of WRC and helping regulators update their regulations. Radio planning, obviously, is one of our kind of key and strong suits. We also do monitoring, testing and commissioning. Another key area is supporting around the licensing and spectrum authorization approaches, as I've mentioned, the challenges around deciding which approaches to take. Plus we do training, particularly we do training in 5G, so that kind of helps with our kind of portfolio of experience. And just to say, we are members of a few organisations that obviously deeply involved in 5G, so the 5G ACIA, for those that are familiar with that, which is very much a focus on connected industries and automation, and the 5G and I now believe 6G IC Innovation Centre at the University of Surrey. I think at this point I'd better stop and just like to thank everyone for your attention. So I'll stop there and go to any questions. So thanks very much. Are there any questions? Right, I should really look at the chat. Okay. Right, so Heiko, you've got a question here. Yeah, we've supported, so a question about supporting governments and regulators developing national strategies. Well, I've just mentioned that we have done that. We've supported a couple of regulators already on developing their 5G national strategy. It's quite, obviously kind of it does vary. As I mentioned kind of quite early on, that there are kind of political drivers. We've certainly seen that there might be a particular focus area, maybe around a technology or a particular sector of that country that may wish to kind of push or promote a particular technology. So it might be kind of automated ports or an automated airport, something like that. But there's been a real focus on, say, the transportation sector, where they want to see some introduction of 5G, developing an ecosystem where they may wish to kind of export a particular solution or technology. So it does vary from country to country how they may wish to implement a national strategy for 5G. So it does vary, which makes it kind of very interesting, of course. Are there any more questions? Please don't be shy. Put some questions on the chat, because this is your opportunity. Oh, thank you. Question from Scott. On the 6 gigahertz issues, what do you consider is the probability that Europe will support IMT in the upper part of the band? Will this decision need to wait under the? Oh, that's a hard question. Okay, I've got. I'll give an answer. I don't mind. So we see a very strong push from, as I said, both sides. I mean, in Europe, I have a feeling that it will wait until after the WRC to make a decision. But what isn't so clear is whether some countries will simply kind of go ahead and make a decision either for IMT or for Wi-Fi. We've seen the decision for the lower portion go towards Wi-Fi. I mean, it makes you wonder whether, you know, being kind of equitable, you say, well, here's 500 megahertz for Wi-Fi, you know, make it very easy, simply, you know, allocate the upper 600 megahertz to IMT, and that would be quite easy. But I'm not sure if it is as straightforward as that. I think we've seen, again, having been involved with some of this kind of directly, that for what this band is going to be used for, having access to that full amount of spectrum, either for IMT or for Wi-Fi, I think if you split it in half, it will just undermine the value of that spectrum, because both sides are arguing that, you know, they want to support, you know, the very ultra wide bandwidths, the use of VR and AR, and I think if you split it either way, you're not really able to do utilize it to the full extent. So my view would be either go for IMT or go for Wi-Fi, but I think, you know, Europe has already made that decision by putting half of it towards Wi-Fi. So if it does decide to do the upper part for IMT, I'm not sure whether that will be, you know, a good outcome necessarily. It might be, but it's very tricky to determine. But very good question and very topical. So thanks very much for that. Kuhn, nice to see you here. Thank you very much for your question. Are you involved in private regulatory spectrum management for enterprise campuses? I know, of course, of Schiphol. Are there others? Yes, we are. We're very much deeply involved in supporting the 5G campus licenses in Germany. Very much on the licensing side of things. So we're supporting kind of enterprises and organisations with their the kind of helping them navigate around the licensing, or you know, application for licenses, technical details. But we are also involved in, you know, supporting on the kind of network architecture, RF design side as well. So yes, we do get involved in that, and obviously there is a kind of that is a growing area, of course, and we're seeing lots more kind of interest in you know, in using our services, I would say, for kind of RF planning and support of deployment of 5G private networks. So it's you know, and I'm sure, as you know, Kuhn, there's a lot of interest in this at the moment. Oh, there's lots of questions coming in now. CH Tan, sorry, that's the only name I've got there, but thanks for your question. Have you had any experience in single wholesale network implementation for 5G? No, not direct experience. Obviously, we've seen this particular example being kind of pushed and promoted. I think it's an interesting model. I think kind of there was an example, kind of single wholesale network example for the likes in Mexico, but that was for 4G. I believe there's also another example elsewhere, but the actual country escapes me for the time being. Not too sure about the popularity of such an option. It does present obviously some issues, but also present some, I think, some advantages as well. It requires a pretty solid kind of wholesale operator, I would say, that really does have to understand the needs of the mobile operators themselves. So almost kind of fully integrated into the kind of mobile market would be, you know, although it sounds like it should be kind of like a neutral host. Predominantly, I think there's more to it than that in some cases, particularly around kind of wholesale access and that kind of thing. But thanks very much for your question. Mahalel El Busaidi from TRA Oman, hello and welcome. Thanks for your question. How can the regulator encourage the mobile operators to deploy SA 5G, standalone 5G, in order to get the full benefits of 5G, so network slicing? How can the regulator encourage? Well, I think the regulators can obviously, you know, I think what regulators are doing in terms of ensuring timely access to spectrum, ensuring, you know, as I mentioned about the kind of access to infrastructure and that kind of thing. I'd say for standalone use is very much I would say, a commercial decision by the operators. What could drive the kind of, to speed up that decision is what I mentioned about the national strategy, is if there's a particular area, like in transport, like in I don't know, industrial automation or industry 4.0, where a particular benefit on productivity or GDP can be attributed, let's say, to the country, and it's only 5G standalone that can really deliver those benefits, deliver the network slicing and so on, and you apply the kind of timescales, expected timescales, so that within 5 years we'd like to see this level of service usage or performance or whatever, implying that it really is only standalone that can deliver those kind of benefits. That would be one way of encouraging kind of the operators to speed that up. But of course, there's a whole kind of level of standards development that kind of sits behind that. And I know there are some standalone kind of early standalone deployments going in now. So I would say definitely in the next 12 to 18 months, we should start to see more and more standalone solutions being deployed for sure. So thank you so much for all of the questions. I very much appreciate that. And there were some really good ones as well. And, certainly helps with the webinar, the interest of the webinar. So thanks very much for that. I guess I should really hand back over to Larissa for the closing remarks.
Thank you, Saul, for these interesting insights. Now that we are slowly coming to an end of this web seminar, please let me say a few words. I'll hurry up, I promise. Please keep in mind that this was only the first web seminar of the series. Over the next 2 weeks, we will have web seminars on our spectrum management tool, MySpectra, and on our radio monitoring tool, LS Observer. You can register for the seminars via our newly established LS Telcom web store, which is actually my baby. So I would be more than happy if you stop by and leave a review on this web seminar. On the store, you will additionally find our training academy offers. The online trainings displayed there, of course, go much more into detail than we have been able to do today. So also, if you haven't so far, feel free to follow us on social media. Besides current web seminar and training offers, you will get unique insights behind the scenes of different areas of LS Telcom and get to know our teams better, and for sure you won't miss any news. If you have further questions concerning our products or services, please feel free to contact us at any time via email. And now let me thank you again, everyone, for joining and tuning in. We would be glad if you keep in touch with us. I hope to see you again during the next web seminars. Until then, I wish you all the best and most important, stay safe.